Good morning. Alrighty, I'm going to take attendance and then we will go through the practice tests. So make sure you have that dug out. So now is the time where I usually have to ask, does anybody need a copy? Practice test? Probably. Dig it. Oh, you got that 8 you got that 8 Another one I thought. The 2 reminders wasn't enough. I do know both 8A and 8B are pink, so, you know, grabbing the wrong one is something that happens. I know. See, that's because you forgot. You need to go with the light. Yes. So my Screencast-O-Matic, which I usually do all the lesson recordings with for the distance learners, is on the fritz. So I'm having to use a Google Meet format to do it instead. But for you, it's not going to make any difference. You know, we need to do the practice tests and know that we are going to be able to do fine next Monday. We take this test. So here it is in all its glory, 10 little problems. In fact, 9 of them are same problems you're going to see on the test, except for different numbers, the 1 through 9. Number 10, I decided last night, I think I'm going to make that one extra credit. So we'll talk about that one when we get there. Because we didn't cover that yet. Normally we cover that in 8.1 to 8.3. So I might put that on as extra credit for you on Monday. All right, let's look at number 1. Simplify each rational expression, state any restrictions on the variable. It all starts by factoring. So we have to remember all of those pieces to factoring. Look at the numerator, 4x squared minus 64. First thing we always check is there a greatest common binomial factor? Can we pull something out of that? No? Factor as is? 4 and 64 are both even, so what at the very least can come out of them? A 2, but does 4 go into 64 evenly? Let's take a 4 out. I want you to think about that x squared minus 16 for a minute, because possibility there that that's factorable, but let's keep going with the denominator at this point. X squared plus 2x minus 8. No greatest common monomial factor. Not a perfect square trinomial, because negative 8 is not a perfect square. Let's try some good old-fashioned factoring on that one. Do we know 2 numbers that multiply to negative 8 and add to 2? Yep. So now, hopefully, when you take a look at that x squared minus 16 on the top, you say, hey, wait a minute, I think I know that pattern. What does x squared minus 16 factor into? Now it's all factored. So this is where we stop and say, these numbers would be bad. We do our restrictions before we do canceling. What would be bad? Exactly. 2 and negative 4, because they make the denominator 0. So x can't be, and we don't have a lot of room on this line, so I'm going to put negative 4 comma 2 just to save on space there. We're almost done. Now if we see some canceling that we can do, we need to do that to simplify it. So see anything you want to cancel? X plus 4s. Can we take anything else? All right, so then we write down what's left on the top and what's left on the bottom. And we take one more look just to double check. Nah, we were right. There wasn't anything else that would come out of that. And then let's put this in a box. That'll make it really easy for me to grade your paper on the test. You know, I can look and see, hey, there's your answer, there's your restrictions, all a go. All right. Hey, 2 is different, but it's multiplication. So it's not. We still need to factor everything. We still need to see what the restrictions are. We still need to cancel like crazy. So it all starts with factoring. Come on, Blue, let's start working. 3x squared minus 2x. Does that have a greatest common monomial factor? And what would it be? What do they both share? Let's take the x out. That's factored now. You know, we don't have any more squared, so it's factored. 9x squared minus 12x plus 4. There's no greatest common monomial factor because 9, 12, and 4, we can't pull anything out, but hey, that might be a perfect square trinomial. This is 3x squared, and this is 2 squared. So help me out. What's 3x times 2?
6x.
Double it. Is that our middle term? It is a perfect square trinomial. So we could write it like that. Are you going to? No, you probably like it as 3x minus 2 times 3x minus 2, right? So either way, it's right. But I think because you have all of your canceling left to do, you'll probably want to write it 3x minus 2 times 3x minus 2. 21x minus 14. Greatest common monomial factor? Oh, let's take a 7. Oh, that's a nice 3x minus 2. We can use that. X. It's x. Perfect time to stop and do our restrictions. We have everything all factored. Let's do the easy one first. What can't this be? Can't be 0. The other one, sometimes people go, oh, I don't remember how to do that. Just remember, we want to know when is it 0. And usually once you write that down, you go, oh, add 2, divide by 3, it's 2/3, you know. Or do the algebra because it's a test, so why not? So x can't be 0, and it can't be 2/3. Well, we're not done yet, because hopefully there's some canceling we can do. What do you see that we can cancel? Yeah. Oh, another 3x minus 2. And the x's. What's left? We are so drastically cool in math. This says 7. We are awesome. Yeah, I know. All these years you just wrote 7 when you could have been writing all of that right there. That is 7. All right. Did I fit 3 down here? I did. Now 3. This one's different. Do you see why? Yeah, this one's division. So we're still going to do all of our factoring, but we're also going to have to do some flipping. So we start by factoring like crazy, find some restrictions, then we flip, find some more restrictions, and then we finish up. X squared minus 4. I think we're supposed to know that one. How do you factor that? Difference of two squares. X squared plus 8x plus 15. No greatest common monomial factor. 15 is not a perfect square, so it must be old-fashioned factoring. Can you come up with the two numbers that make it work? Divided by, don't do any flipping yet, or you're going to miss a restriction. X squared minus x minus 2. No greatest common monomial factor, not a perfect square trinomial. Good old-fashioned factoring, it is. Pardon me. Good afternoon, Mrs. Cedarholm. Hi. Oh, see, I've had technology issues all day, so I haven't even gotten my email. Will do. 6 hours my prep. Yep, bye. Okay, sorry about that. Did you already factor it? What'd you get? Yeah. X minus 2, x plus 1, x squared plus 7x plus 10. No greatest common monomial factor. Not a perfect square or anything. What do you have for that one? Yeah. Now we have to stop because we have to write down restrictions at this point. We can see all of those denominators. So what numbers are bad? And I'm going to put them in number line order. You wouldn't have to. I'm going to take them however, but it's just going to drive me nuts if I don't change that there. So far, that's all the restrictions we have? Yeah, because x plus 5 showed up twice, right? All right. Now we have to flip. Not the first one. You flip what you're dividing by. So I'm going to put some equals in here to break this up a little bit. First one stays put. But what you're dividing by gets flipped. So the one after the division symbol, which means we may have new restrictions to the denominator because we just made a new denominator. Any more numbers that are out? -1 and 2. Yep. Got them. Now what should we do? Yeah, if we see anything we can cancel, we need to do it now. So what do you got? X plus 5? That's everything? Okay. So on the top, we have an x plus 2 times x plus 2. Let's simplify that. Let's write that as x plus 2 squared now that we're done. And on the bottom, x plus 3 and x plus 1. And we get a second look at, hey, did we miss something? You know, is there something that's still on the top and the bottom that we could cancel? Nope. We did it. Yay, us. There's our answer. There's our restrictions. So we did simplify, multiply, and divide. Now we switch gears. Why is adding and subtracting fractions more difficult than multiplying and dividing? You have to have the denominators the same. So the first thing we do is we try to factor the denominators, but those are as factored as they're going to get. And for the people that look at this later, I want them to be able to see what the original was. But then our next step after factoring is we have to find the LCD. They have to have a common denominator. Doesn't have to be the least, but that would be the best one. So what would our LCD be for those two little honkers? Yep, because everything has to be there and to its highest power. And they're both just first power. So now we look at our denominators and we realize they're missing something. This one needs the x minus 7 on the top and the bottom. And this one needs the x plus 7 on the top and the bottom. And if it drives you bonkers that they don't have parentheses around the x plus 7 and x minus 7, put them on yourself. Now we're going to distribute 3x minus 21 for x minus 7 times x plus 7 plus x squared plus 7x over x minus 7 plus x plus 7. Can we finally add these two things together? Yeah, we've got that common denominator. So across the top, we add, and we get x squared plus 10x minus 21. Now notice, with adding and subtracting, no canceling until now, at the very end. At the very end, if we can factor and cancel, we do. It happens every year. Somebody gets to this point and they start working backwards. And then I can't give them the points for this problem. With adding and subtracting, you've got to get them together, then do your reducing if you can. So the only way we would be able to do some canceling is if we can come up with the factorization of x squared plus 10x minus 21, and it happens to match what we have on the bottom. So let's see. There's no greatest common monomial factor. It's not a perfect square trinomial, because that's negative 21. So maybe some good old-fashioned factoring. We need two numbers that multiply to negative 21 and add to positive 10. But that won't multiply to positive 21. Or it will multiply to positive 21. Here I'm saying it won't. That'll be positive 21. Negative 7 times negative 3 will be plus 21. We have anything? It was done. It was done. Yeah. There are not two integers that multiply to negative 21 and add to 10. We were done. See how that's kind of a trick question? Because they're hoping we do 7 and 3. Yeah, they're hoping we do that. But that's done. All right. We didn't have to give restrictions anywhere, did we? And I just wrote way too long here and can't see it anymore. Nope. Directions don't say it. We don't have to do it. No restrictions for those. There are restrictions. I'm not going to take off points if you do them, but we don't have to on these. Alrighty. Number 5. Step 1. Change subtraction to adding a negative. That was in a video lesson for Friday, which some of you like to forget that you have school on Fridays. Yeah. Change it to adding a negative. And you'll notice I didn't do anything about the denominator in the first one because I don't think that's done. How do you factor x squared minus 81? Bless you. So now we can talk LCD. What will our LCD be for those two little fractions there? Yep, got to have everything into its highest power. That's it. So this little bugger only has the x minus 9. So it needs the x plus 9. That means we have to do a little distributing. Can we finally add them? Yeah, they have a common denominator now. So we can finally do what we needed to do, which was add. So that would give us negative x minus 63 over the quantity x plus 9 times the quantity x minus 9, unless we can do some factoring and some canceling. Can we factor that numerator? Yes, we can pull a negative out. We need to show that. You know, I can't talk to you while you're taking your test. You can't call me over and say, Cedar, I might pull a negative out of these two, but it's not going to help anyway because they won't cancel. You can't do that. So you show me you knew to do this. And you knew there wasn't any more math you could do. And you were done. Happens. You know, we've done tons of factoring at this point in the year, so we have to show off all those skills. Well, we added and subtracted. Now we can flip the page. And we can do a complex fraction. When we simplified complex fractions earlier, we had 3 letters to kind of guide us to what we had to do. Actually, 4 letters, but 3 separate pieces that we did. Anybody remember? Okay. How about if I give you a hint? Yeah. Denominator. XR. NDXR. Numerator, get it to be 1 fraction. Denominator, get it to be 1 fraction. Then multiply by the reciprocal so you can do the division. So right now, this is 2 plus 3 over x. But if we want everything to be fractions, we're going to write it as 2 over 1. And then we're going to come up with an LCD so we can do the addition. What's the LCD of 1 and x? X. So it turns out just this first little bugger needs that. So that didn't take too long. Step 1. Done. Let's go to denominator. Write it all as fractions. Always easier when you're working with fractions to have everything be fractions. LCD. Y. First one needs a little y on the top and the bottom. That wasn't so bad either. XR. Leave the numerator alone. We did our simplifying. It was 2x plus 3 over x. But now multiply by the reciprocal of your denominator. Oh, my 2 looks kind of small. That's better. Hey, now it's multiplication. That means if we can cancel, now's the time. Can we cancel anything? Well, that's kind of a bummer. So all we can do is top times top and bottom times bottom. Oops, almost forgot the 7. But it's done. And we did it. 1 fraction for the numerator, 1 fraction for the denominator, multiplied by the reciprocal. It's the right answer. That's what we needed to do. So that's a complex fraction. When we covered that section, I had told you, we're not going to give you the hardest ones that we covered from complex fractions. And this definitely is not from the hardest stuff that we did. Alrighty. Solving. Well, that's different because when we're solving, if we don't have to work with fractions, why would we? You know, we'd get rid of them. So what we do for solving, and notice the directions, solve the equation and check each solution. Slap a 1 under there. And let's find the LCD. What is the LCD? Bigger. 10. So we multiply all three of these terms by 10. But we're going to be able to do a little canceling. 5 goes into 5 once and into 10 twice. So that first term will now be 2x plus 2 goes into 2 once and into 10 5 times. Leaves us with 5x. 14 times 10 happens to be 140. Hey, that's some really basic algebra we're looking at there. 2x plus 5x is 7x. Divide. And I go on to number 8. And I lose a point. Yeah. Remember, when we went through this section, they kept hitting us over the head with a hammer and saying, check for extraneous solutions. Well, that's what we got to do. 20 over 5 plus 20 over 2, does that really equal 14? And for some of you, that's all you're going to have to write, because you go, oh, that would be 4, that would be 10. Yes, it's 14, check. But if you want to show a little bit more work, I'm cool with that too. It worked. 8 is different. Huh. 8 has a fancy name. When one fraction equals another fraction, it's called a proportion. There's an easier way to solve proportions than normal equations like we see in number 7. Anybody remember it? You do. You cross multiply. This times this equals this times this. Let's distribute. We've got y's on both sides. We should try to get those together. Subtract them. Which one? Yep. We usually take the smaller one, keep the y's positive. He's ready to do this. Math is cool. Remember 7? Did you already forget about 7? Now what? Add the 12. Maybe, right? Yeah, and you have to show that you're checking it. So let's put the numbers in. 4 over 16 minus 2 equals 6 over 16 plus 5. 4 over 14 equals 6 over 21. Yeah, reduce them. Reduce this one by 2. Reduce this one by 3. It's good. If you don't want to do that reducing in your head, remember your calculator does reducing. So could use that. Oh, it might be down here. Nope. It's right here in the middle of the blue stuff. Come on. Now, is number 9 a proportion? It's not one fraction equals one fraction, right? So we go back to what we were doing in number 7. Hey, they already have nice little denominators for us. We don't have to factor or anything. All we have to do is figure out the LCD. What would it be for those 3 lovely little fractions? 3x squared. Everything's there and to its highest power. So we're going to multiply all 3 terms by 3x squared. Stay at home. Should we change that to plus a negative? Do you see how this is probably not the most complicated equation we've ever done? So you wouldn't have to. I don't think you're going to lose the negative on this one because we're not multiplying by a binomial or anything like that. But you certainly could. If you're worried about this subtraction, change it to adding a negative, just so you don't make that mistake. Here, the 3 and 1 of the x's cancel out. So we have 1x left. X times 11, 11x. Here, the 3's cancel out, and we have negative 1 and x squared. So minus x squared. Here, the x squareds cancel out, and we have negative 4 times 3, which is negative 12. And that doesn't look like the answer that we had for problem 7 at this point. Because it has a squared. And it has next to the first. And it has a number. That makes it a quadratic. That's a parabola. Parabolas usually have 2 spots where they hit the x-axis. And we find those 2 spots by factoring. You know where factoring has come in tons on this test? Here it is again. But to factor it, it all has to be on one side. And I don't want this to be negative. So I think I'm going to move both of these over here. So if you have a negative x squared, then the first thing you have to do is factor out a negative, and then you have to do the normal factoring. And, well, that's kind of a pain, so don't want to do that. No greatest common monomial factor. Definitely not a perfect square with a negative 12 in the back. Good old-fashioned factoring time. You got them? What works? We're one step away from our answers. What would our 2 answers be if we have those 2 binomials? If they both work. So let's check them. So the first one I'm going to check is the 12. So here's the original. 11 over 3 times 12 minus 1/3 equals negative 4 over 12 squared. 11 over 36 minus 1/3 equals negative 4 over 144. Now's the time for honesty, because I can do this by hand and show you how to do it by hand, but are you going to check it with your calculator? Well, then I'm going to use the calculator up here to show you. So we've got, I better move it down first so I can see it. Parentheses, 11 divided by 36, parentheses, minus parentheses, 1 divided by 3, parentheses. And then we want to check out negative 4 divided by 144. Are they the same? Check. And then we'll check negative 1. And move this up again. Back and forth, back and forth. Come on, Blue. 11 over 3 times negative 1 minus 1/3. Does that equal negative 4 over negative 1 squared? Well, let's see. 11 over negative 3, or negative 11/3, minus 1/3. Does that equal negative 1 squared is 1. So negative 11/3 minus 1/3. Is that true? Negative 12 divided by 3, does that equal negative 4? It's good. So that one had 2 solutions that both worked. In fact, let me put a box around my 2 solutions. So on the test, that will be the end of the normal part, 1 through 9. Now, like I said, last night I was thinking about this one. It's that I think you guys can do this. I think the majority could do this. I think I'll make this extra credit. So I'll leave it on this test. But you have to do much more on this one than me, because this is going to be extra credit. Now, let's read it, and let me talk you through parts of it. How many milliliters of 0.6% saline solution must be added to 100 milliliters of 5% saline solution to get a 0.09 or 0.9%, sorry, putting too many zeros in there, solution? Use this equation. And at first, you go, what on earth? But watch this. How many milliliters of 0.6%? Well, you can't use percentages in math formulas, so they'd have to change that to 0.006. How many milliliters, 0.6%, must be added to 100 milliliters of 5%? 100 milliliters, 5%, to get 0.9%. Oh, that's not up there yet, is it? So where is the 0.9% going to go in this equation? It will. And we have to change it into a decimal. What would it be as a decimal? And you might want to clean this up a little bit. We know that 100 times 0.05 is 5. So kind of silly to leave it that way. I'm also going to put the X's in the back. So 0.006, although that 0 looks really honky. 006. And I'm going to put X plus 100 on the bottom too. Doesn't make any difference. When you solve it, you'll get it. Looks like so. Remember, this needs to be more you than me. What would you do? You're out of ideas. I should just count you out on the extra credit tomorrow. Oh, that's good thinking, isn't it? I mean, when you have a fraction equal to a fraction, you cross multiply, right? Ben. Come on, you're already doing it. What are you doing? Distributing. All right, let's do that. Then what? $1,366 and 2/3 milliliters. Now, I would say for most people, you'd think, well, I must have done something wrong because that is an awfully big number. Until I remind you what saline is. If you've ever been in a hospital visiting somebody that's very sick that has an IV, there are those big bags that are hanging next to them. Those are IV bags made with milliliters of saline and sometimes other additives in there. Those big bags are 1,000 milliliters. Here's why. Have you ever used eye drops? One little drop is a milliliter. Just one little drop. So you would need a lot of these to make this happen. That's the right answer. You did it right. So not only should everybody ace this one on Monday, they should above ace it with extra credit on there, right? Piece of cake? Except there are some of you that say this to yourself in your head. Well, now that we did the practice test together, I don't have to do the assignment. Because if I have the practice test and I know what I'm doing, I'm going to be just fine. Really? So that would mean you believe that in these 10 problems, we have seen every type of factoring known to man. You need practice. So here it is. The good news is you have till Monday for this. So you can do a little bit today. Tomorrow, you're not going to have a new video or anything like that. Do the rest of the homework tomorrow. And test is on Monday.
Cool. I'm coming.
So yeah, this would be a great test for everybody.